What happens when an entire military doctrine collapses in a single afternoon? On June 22, 1941, Operation Barbarossa launched with unprecedented confidence from German high command. Wehrmacht strategists had calculated every variable: Soviet industrial capacity, troop deployments, geographic obstacles, weather patterns, and most critically, armored vehicle capabilities. German intelligence had meticulously catalogued Soviet tank inventories, concluding that Red Army mechanized units possessed obsolete equipment incapable of meaningful resistance against proven German panzer divisions. The invasion commenced across a front stretching 2,000 kilometers from the Baltic Sea to the Black Sea. German forces deployed 3,800 tanks, primarily Panzer III and Panzer IV models that had demonstrated devastating effectiveness across Poland, France, and the Low Countries. These vehicles carried 50mm and 75mm guns, respectively, armor thickness ranging from 30 to 50mm, and sophisticated optical equipment. German tank crews had accumulated extensive combat experience, developing tactical procedures that maximized their equipment's advantages while exploiting enemy weaknesses. Soviet tank production in 1941 centered around three primary models: the T-26 light tank, BT-7 fast tank, and T-28 medium tank. Intelligence reports accurately described these vehicles as mechanically unreliable, poorly armored, and inadequately armed. The T-26 carried a 45mm gun with minimal armor protection. BT-7 tanks emphasized speed over protection, featuring thin armor plates vulnerable to standard anti-tank weapons. T-28 medium tanks, while larger, suffered from complex mechanical systems prone to breakdown under field conditions. Manufacturing quality across Soviet tank production reflected broader industrial challenges facing the Soviet Union. Stalin's rapid industrialization program had prioritized quantity over quality, establishing production quotas that often compromised manufacturing standards. Tank crews received minimal training on vehicle maintenance, tactical deployment, or coordinated operations. Communication systems remained primitive, limiting battlefield coordination between individual tanks or integration with infantry and artillery support. Geographic considerations seemed to favor German advancement. The Western Soviet Union featured relatively flat terrain ideal for mechanized warfare, with limited natural barriers that could slow armored spearheads. Major rivers ran north-south, paralleling rather than blocking German east-west advance routes. Road networks, while primitive by German standards, provided adequate movement corridors for tracked vehicles. Weather conditions in June offered optimal visibility and ground firmness for tank operations. Political circumstances within the Soviet military further complicated defensive preparations. Stalin's purges of 1937 to 1938 had eliminated experienced tank commanders, replacing them with politically reliable but tactically inexperienced officers. Military doctrine emphasized offensive operations rather than defensive tactics, leaving commanders unprepared for conducting fighting withdrawals or establishing defensive positions. Communication between frontline units and higher command suffered from bureaucratic inefficiency and political intimidation. German tank crews entered Soviet territory expecting encounters with known enemy vehicles. Training manuals detailed standard engagement procedures against T-26 and BT-7 tanks, emphasizing optimal firing ranges and ammunition selection. Maintenance crews had stockpiled replacement parts for anticipated German tank damage, calculating repair times based on previous campaign experiences. Artillery units coordinated anti-tank support, assuming Soviet armor would conform to established performance parameters. Industrial production schedules reflected German confidence in campaign duration. Tank manufacturing plants maintained standard peacetime production rates, anticipating that existing inventory would suffice for Soviet operations. ammunition production focused on standard armor-piercing rounds effective against known Soviet tank models. Spare parts distribution prioritized European theater requirements over extended Eastern campaign logistics. Soviet industrial capacity appeared inadequate for sustained tank production under wartime conditions. Major manufacturing centers concentrated in western regions vulnerable to German bombing or ground assault. Transportation networks lacked redundancy necessary for relocating production facilities. Raw material stockpiles seemed insufficient for extended conflict duration. Skilled workers possessed limited experience with complex mechanical systems required for tank manufacturing. Military leadership on both sides operated under assumptions that would prove catastrophically wrong within weeks. German commanders expected rapid tank engagements followed by swift territorial gains and Soviet collapse. Soviet officers anticipated brief defensive actions before launching counteroffensives with existing equipment. Neither side had prepared for extended tank-versus-tank combat, requiring technological adaptation and tactical innovation. Intelligence gathering had failed to identify critical developments within Soviet tank design programs. German reconnaissance focused on visible equipment, rather than investigating research and development activities. Soviet security successfully concealed new tank prototypes from foreign observation. Communication barriers prevented accurate assessment of Soviet industrial capabilities and technological advancement. Both militaries entered combat with incomplete understanding of their opponent's actual capabilities. The stage was set for confrontation between military forces, whose leaders believed they understood their enemy's strengths and limitations. German tank crews approached Soviet borders confident in their equipment's superiority and their own tactical expertise. Soviet tank units prepared for combat using doctrine and equipment that High Command considered adequate for defensive requirements. Neither side anticipated that fundamental assumptions about armored warfare were about to be violently challenged by battlefield realities that would reshape military thinking for decades. Lieutenant Hans Weber had destroyed 17 Soviet tanks during the first 3 weeks of Operation Barbarossa, each engagement following predictable patterns established through extensive training and combat experience. German tank crews approached Soviet armor encounters with systematic methodology: identify target type, select appropriate ammunition, engage at optimal range, confirm destruction, advance. This procedure had functioned flawlessly against T-26 light tanks and BT-7 fast tanks, achieving kill ratios exceeding 5-to-1 in favor of German forces. On July 15, 1941, Weber's Panzer III encountered something unprecedented during a reconnaissance mission near Seno in Belarus. His gunner identified what appeared to be a standard Soviet medium tank approaching through morning mist. Weber ordered standard engagement protocol: 50mm armor-piercing round, range 800 meters, target center mass. The shot struck squarely but produced no visible effect. The unknown Soviet tank continued advancing, apparently undamaged. Weber ordered a second shot using tungsten core ammunition reserved for heavily armored targets. Impact occurred precisely where aimed, yet the enemy tank maintained course and speed. Weber's radio operator frantically contacted headquarters requesting identification assistance, while his driver maneuvered for better positioning. The Soviet tank's turret rotated smoothly toward Weber's position, revealing a gun barrel significantly larger than anything documented in German intelligence files. The return shot penetrated Weber's frontal armor effortlessly, killing his gunner instantly and setting ammunition storage ablaze. Weber and his surviving crew abandoned their vehicle as secondary explosions destroyed equipment they had considered invulnerable. Similar encounters occurred simultaneously across multiple sectors of Army Group Center's advance, creating confusion and alarm throughout German tank units. German field reports described enemy vehicles demonstrating impossible characteristics. Armor thickness appeared to exceed 60 millimeters on frontal surfaces, rendering standard 50mm anti-tank guns ineffective at normal combat ranges. Main armament consisted of 76mm guns, capable of penetrating German armor at distances exceeding 100 to 200 meters. Vehicle mobility matched or exceeded German tank performance, despite apparently heavier construction. Tank recovery teams discovered additional disturbing details while examining disabled German vehicles. Penetration patterns indicated Soviet ammunition possessed superior metallurgy and ballistic characteristics. Crater analysis revealed explosive charges more powerful than standard high-explosive rounds. Track impressions suggested enemy tanks weighed significantly more than intelligence estimates while maintaining mechanical reliability under combat conditions. German tank crews reported psychological impacts beyond mechanical concerns. Confidence accumulated through successful campaigns evaporated when standard tactics failed repeatedly. Crew morale declined as casualty rates increased dramatically from previous operations. Sleep deprivation intensified as crews remained constantly alert for encounters with unidentified enemy vehicles. Stress-related mechanical errors increased as crews rushed through maintenance procedures while expecting immediate combat. Artillery support proved inadequate against these unknown Soviet tanks. Standard anti-tank guns firing 37mm rounds achieved no penetration against frontal armor. 50mm towed guns required direct hits at ranges under 400 meters to achieve reliable penetration. 75mm artillery needed close coordination and favorable positioning to engage effectively, conditions rarely available during fluid combat situations. Air support encountered similar difficulties. Luftwaffe pilots discovered that standard machine gun strafing produced no visible damage against these Soviet tanks. Bombing attacks required direct hits with large ordnance to achieve destruction, accuracy levels difficult to maintain during low-altitude attack runs. Close air support coordination became complicated by inability to quickly distinguish between different Soviet tank types from aerial observation. Intelligence failures cascaded throughout German command structure. Field commanders lacked technical specifications for enemy equipment they encountered daily. Tactical manuals contained no guidance for engaging armored vehicles with characteristics exceeding documented parameters. Communication delays prevented rapid dissemination of lessons learned from frontline encounters. Higher headquarters dismissed initial reports as exaggerated or inaccurate. Supply chain disruptions compounded tactical difficulties. Ammunition consumption increased dramatically as crews expended multiple rounds per target engagement. Tungsten core ammunition, previously reserved for special situations, became standard requirement, consuming stockpiles faster than replacement deliveries. Tank replacement demands exceeded peacetime production schedules, straining manufacturing capacity and transportation networks. Maintenance requirements intensified as German tanks sustained previously uncommon types of damage. Armor penetration repairs required specialized welding equipment and replacement armor plates not readily available in forward areas. Track damage increased due to hasty maneuvering during combat, consuming spare parts faster than anticipated. Engine wear accelerated as crews operated vehicles at maximum performance parameters for extended periods. Combat effectiveness declined measurably across German tank units. Average engagement ranges increased as crews sought safer distances from enemy fire, reducing accuracy and requiring more ammunition per target. Tank versus tank combat durations extended significantly, exposing German vehicles to additional threats and consuming fuel reserves. Mission completion rates decreased as units devoted increasing time to equipment replacement and crew recuperation. The fundamental problem became undeniable. German intelligence had failed to identify a Soviet tank that fundamentally challenged German armored warfare doctrine. This vehicle combined protection, firepower, and mobility in ways that existing German equipment could not effectively counter. Standard German tactics required immediate modification to address an enemy whose capabilities exceeded all previous planning assumptions. The systematic advantages that had powered German success across Europe were being systematically negated by an opponent whose existence had been completely unknown to German military leadership. Mikhail Ilyich Koshkin never intended to revolutionize armored warfare. Born in 1898 to a peasant family in Yaroslavl province, he began his career as a candy maker's apprentice before the Russian Revolution redirected his life toward mechanical engineering. His background placed him among thousands of Soviet citizens whose technical education emerged from practical necessity rather than formal training. Individuals whose unconventional perspectives often produced innovative solutions to complex problems. Koshkin's entry into tank design occurred almost accidentally. After completing technical education at Leningrad Technological Institute, he joined the Kharkov locomotive factory in Ukraine, initially working on railroad equipment. His mechanical aptitude and problem-solving abilities attracted attention from supervisors who transferred him to the factory's newly established Tank Design Bureau in 1934. This assignment positioned him to observe firsthand the limitations of existing Soviet tank designs. The Design Bureau operated under constant pressure to improve Soviet tank capabilities while working with limited resources and outdated equipment. Koshkin's colleagues included experienced engineers whose previous projects had produced mixed results. The T-26 light tank, while adequate for infantry support, lacked armor protection necessary for independent operations. The BT series emphasized speed at the expense of protection and reliability. The T-28 medium tank attempted to balance multiple requirements but achieved mediocrity rather than excellence in any specific characteristic. Koshkin's engineering philosophy differed fundamentally from established Soviet design approaches. Rather than accepting predetermined specifications and optimizing individual components separately, he insisted on examining overall system integration. His methodology emphasized practical field requirements over theoretical performance parameters. He spent extensive time consulting with tank crews about operational challenges, maintenance difficulties, and combat effectiveness limitations. Soviet tank doctrine in the mid-1930s reflected confusion between competing strategic concepts. Some military theorists advocated for light, fast tanks supporting infantry advances. Others argued for heavily armored breakthrough vehicles capable of independent operations. Budget constraints prevented development of specialized vehicles for different roles, forcing designers to create compromised solutions that performed inadequately across multiple mission requirements. Koshkin's team received authorization in 1937 to develop a replacement for the aging T-26 and BT series tanks. Initial specifications called for a vehicle weighing no more than 16 tons, mounting a 45mm gun, and achieving speeds exceeding 35 kilometers per hour. These parameters reflected existing Soviet production capabilities and transportation limitations rather than optimal combat effectiveness requirements. The design process revealed fundamental flaws in established Soviet tank development procedures. Component selection prioritized availability over performance, resulting in mechanical systems prone to breakdown under field conditions. Armor design emphasized manufacturing simplicity rather than ballistic protection, producing vehicles vulnerable to contemporary anti-tank weapons. Crew accommodations received minimal attention, creating working conditions that degraded combat effectiveness during extended operations. Koshkin challenged these conventional approaches by proposing radical design modifications. He advocated for sloped armor plates that would provide enhanced protection without proportional weight increases. His team investigated larger caliber guns that could penetrate anticipated enemy armor improvements. They redesigned internal layouts to improve crew efficiency and equipment reliability under combat stress. Political pressures complicated technical decision-making throughout the design process. Stalin's purges eliminated experienced tank commanders whose operational insights might have guided development priorities. Factory managers prioritized production quotas over quality improvements, creating incentives for conservative design choices. Political officers monitored design discussions for deviation from approved doctrine, discouraging innovative thinking that might be interpreted as criticism of existing policies. Koshkin's most controversial innovation involved abandoning the wheel-track suspension system used in BT series tanks. This decision eliminated operational complexity while reducing manufacturing costs and maintenance requirements. Critics argued that removing road wheels would decrease strategic mobility by limiting highway speeds. Koshkin insisted that improved cross-country performance and mechanical reliability outweighed highway speed advantages that provided limited tactical benefit. Armor configuration represented another area where Koshkin's team departed from conventional practice. Rather than using vertical armor plates that maximized internal volume, they designed sloped surfaces that deflected incoming projectiles more effectively. This approach required redesigning internal arrangements to accommodate angled surfaces, increasing design complexity while significantly improving ballistic protection without weight penalties. The prototype, designated T-34, incorporated dozens of technical innovations that individually appeared minor but collectively transformed overall vehicle capabilities. Improved metallurgy produced armor plates with enhanced hardness characteristics. Redesigned transmission systems provided better power distribution and reduced maintenance requirements. Modified crew arrangements improved battlefield coordination and reduced fatigue during extended operations. Testing revealed performance characteristics that exceeded original specifications substantially. Armor protection proved effective against existing anti-tank weapons at normal combat ranges. Mobility performance surpassed comparable German and British vehicles despite heavier construction. Main armament demonstrated superior ballistic performance compared to contemporary tank guns. Mechanical reliability exceeded expectations based on previous Soviet tank experience. Koshkin's personal dedication to the project extended beyond normal engineering responsibilities. He participated in extensive prototype testing, often under harsh weather conditions that revealed design weaknesses requiring immediate correction. His insistence on personally verifying vehicle performance ensured that theoretical calculations matched practical capabilities. This hands-on approach identified problems that might have remained undetected until mass production commenced. The T-34 design represented a convergence of technical innovation, practical experience, and strategic insight that transformed Soviet armored capabilities. Koshkin's background as a practical engineer, rather than theoretical designer, enabled him to prioritize battlefield effectiveness over academic elegance. His willingness to challenge established conventions produced solutions that conventional thinking would never have discovered. The tank that emerged from his team's efforts would soon demonstrate capabilities that would surprise both Soviet leadership and German opponents who believed they understood the limits of Soviet technological achievement. Colonel Erhard Raus commanded the 6th Panzer Division's advance elements when his reconnaissance units reported impossible Soviet tank encounters on July 23, 1941, near Rasenia in Lithuania. German intelligence had predicted encountering T-26 and BT-7 tanks during the Baltic offensive, equipment that posed minimal threat to experienced German tank crews. Instead, Raus discovered his division facing armored vehicles whose capabilities fundamentally challenged German tactical doctrine and equipment effectiveness. The first confirmed T-34 encounter occurred during a routine advance through apparently abandoned Soviet positions. German tanks approached what appeared to be a disabled Soviet vehicle, partially concealed behind earthwork fortifications. Standard procedure called for infantry reconnaissance, followed by tank destroyer teams clearing suspected anti-tank positions. However, the mysterious Soviet tank suddenly activated, demonstrating mobility that startled German observers. Captain Heinrich Eichler, commanding a Panzer IV, fired the engagement's opening shot at 600-meter range, anticipating routine destruction of enemy armor. His 75mm armor-piercing round struck the Soviet tank's turret front squarely, producing a bright flash. and metallic ringing sound. The target continued operating normally, rotating its turret toward Eichler's position with mechanical precision that suggested undamaged fire control systems. The return shot penetrated Eichler's frontal armor effortlessly, despite the Panzer IV's 50mm protection that had proven adequate against all previous enemy encounters. Armor penetration created a fist-sized hole through which Soviet ammunition entered the fighting compartment, igniting stored rounds and hydraulic fluid. Eichler and his crew escaped their burning vehicle, while secondary explosions destroyed equipment worth months of German industrial production. German tank recovery teams examining disabled vehicles discovered technical characteristics that contradicted every assumption about Soviet industrial capabilities. T-34 armor plates measured 45 millimeters thick on frontal surfaces, but featured sloped angles that effectively doubled ballistic protection. Metallurgical analysis revealed steel hardness exceeding German armor specifications, suggesting sophisticated heat treatment processes that intelligence estimates had declared beyond Soviet technological capacity. The T-34's 76mm F-34 gun demonstrated ballistic performance superior to comparable German weapons. Captured ammunition featured tungsten core penetrators capable of defeating German armor at ranges exceeding 1,000 meters. Barrel length and chamber pressure specifications indicated Soviet weapons technology had advanced significantly beyond intelligence estimates. Optical equipment quality matched or exceeded German standards, despite expectations of inferior Soviet precision manufacturing. Mechanical examination revealed engineering solutions that German designers had not considered. Christie suspension systems provided exceptional cross-country mobility while maintaining mechanical reliability under combat stress. Wide tracks distributed vehicle weight effectively, enabling operations in soft terrain that immobilized German tanks. Engine performance delivered adequate power while consuming less fuel than comparable German power plants. German field commanders reported that standard anti-tank tactics proved ineffective against T-34 encounters. 37mm anti-tank guns required multiple direct hits to achieve penetration, accuracy levels impossible to maintain under combat conditions. 50mm guns needed close-range engagements that exposed crews to Soviet return fire. 75mm artillery required favorable positioning rarely available during mobile operations. Infantry anti-tank capabilities proved equally inadequate. Standard anti-tank rifles firing steel core ammunition achieved no penetration against T-34 armor at any practical range. Handheld anti-tank weapons lacked sufficient explosive power to damage heavily armored Soviet vehicles. Magnetic anti-tank mines required close approach that exposed personnel to machine gun fire from tank-mounted weapons. Air support encountered similar difficulties engaging T-34 tanks effectively. Machine gun strafing produced no visible damage against sloped armor surfaces. Standard bombing attacks required direct hits with large ordnance to achieve destruction. Accuracy levels difficult to maintain during low-altitude attack runs. Close air support coordination became complicated by pilots' inability to distinguish T-34s from other Soviet vehicles during rapid identification procedures. German tank crews reported severe psychological impacts from encountering invulnerable enemy vehicles. Confidence accumulated through successful campaigns evaporated when proven tactics failed repeatedly. Crew cohesion deteriorated as casualties increased dramatically from previous operation rates. Combat effectiveness declined as crews became increasingly cautious, reducing aggressive maneuvers that had previously characterized German armored tactics. Supply chain disruptions cascaded throughout German logistical systems. Ammunition consumption increased dramatically as crews expended multiple rounds per target engagement without achieving destruction. Tank replacement demands exceeded peacetime production schedules as T-34 encounters resulted in total German vehicle losses rather than repairable damage. Spare parts consumption accelerated due to equipment stress from prolonged engagements. Combat reports filtering through German command hierarchy described encounters that senior officers initially dismissed as exaggerated or inaccurate. Frontline accounts of invulnerable Soviet tanks contradicted intelligence estimates and strategic planning assumptions. Communication delays prevented rapid dissemination of tactical lessons learned from T-34 encounters. Higher headquarters required extensive verification before acknowledging that fundamental assumptions about Soviet capabilities required immediate revision. Tank versus tank engagement patterns shifted dramatically as German crews adapted to T-34 capabilities. Average combat ranges increased as German tanks sought safer distances from Soviet fire, reducing accuracy and increasing ammunition consumption. Engagement durations extended significantly as multiple German vehicles coordinated attacks against individual T-34s. Mission completion rates decreased as tank units devoted increasing time to equipment replacement and crew recuperation. The realization struck German commanders gradually, and then suddenly. Soviet industrial capacity had produced a tank that challenged German armored superiority fundamentally. The T-34 combined protection, firepower, and mobility characteristics that exceeded German equipment capabilities across multiple parameters. Standard German tactics required immediate modification to address an enemy whose battlefield presence invalidated 3 years of successful armored warfare doctrine. The systematic advantages that had powered German victories across Europe were being systematically challenged by an opponent whose technological capabilities had been completely underestimated by German military intelligence. German Panzer Group commanders faced an immediate crisis requiring systematic tactical modifications across all armored units by August 1941. General Heinz Guderian issued emergency directives mandating coordinated attacks against individual T-34 tanks, abandoning previous doctrine emphasizing rapid single-vehicle engagements. German tank crews received instructions to engage Soviet armor only when numerical superiority exceeded 3-to-1 ratios, fundamentally altering offensive operational tempo that had characterized successful blitzkrieg campaigns. Tank destroyer units underwent rapid reorganization to address T-34 threats that standard equipment could not engage effectively. German engineers accelerated development of longer-barreled 50mm guns capable of penetrating Soviet armor at practical combat ranges. Emergency modifications equipped Panzer IV tanks with improved 75mm guns featuring higher muzzle velocities and tungsten core ammunition. Production priorities shifted from quantity to firepower enhancement as German industry recognized the inadequacy of existing weapons. Artillery doctrine required fundamental revision to support tank operations against heavily armored Soviet vehicles. German commanders coordinated direct fire missions using 88mm anti-aircraft guns capable of penetrating T-34 armor reliably. Field artillery units received training in anti-tank roles, despite reduced effectiveness against mobile armored targets. Forward observer procedures integrated tank artillery coordination more closely to mass firepower against individual high-value targets. Luftwaffe close air support missions adapted to address T-34 encounters that ground forces could not resolve independently. Pilots received enhanced training in precision bombing techniques necessary to destroy heavily armored targets. Aircraft armament improvements included larger caliber guns and specialized anti-tank ammunition. Ground attack squadrons coordinated more closely with tank units to provide concentrated firepower during armored engagements. German industrial mobilization accelerated dramatically as leadership recognized the technological gap revealed by T-34. Tank production schedules prioritized firepower improvements over quantity increases. Ammunition manufacturing shifted toward tungsten core rounds despite raw material shortages. Metallurgical research intensified to develop armor protection equivalent to Soviet capabilities demonstrated in combat. Tactical training programs incorporated lessons learned from T-34 encounters, emphasizing coordination and firepower concentration over individual tank capabilities. German crews practiced flanking maneuvers designed to engage Soviet armor from vulnerable sides and rear aspects. Communication procedures improved to enable rapid coordination between multiple vehicles during extended engagements. Maintenance training addressed increased equipment stress from prolonged combat operations. Soviet tank production responded to German tactical adaptations by increasing T-34 manufacturing rates substantially. Factory 183 in Kharkov expanded production from 100 tanks monthly in early 1941 to over 500 monthly by year's end. Quality control procedures improved to ensure consistent armor protection and mechanical reliability. Crew training programs enhanced to maximize T-34 tactical advantages against German countermeasures. T-34 design modifications addressed German tactical responses while maintaining production efficiency. Upgraded armor protection increased frontal thickness to 60 mm without significantly impacting manufacturing complexity. Improved ammunition types enhanced penetration capabilities against upgraded German armor. Radio equipment standardization improved coordination between T-34s during coordinated operations. German intelligence operations intensified efforts to understand Soviet tank development capabilities and production capacity. Reconnaissance missions focused on identifying T-34 manufacturing facilities for potential bombing campaigns. Technology assessment teams analyzed captured vehicles to determine Soviet metallurgical and engineering capabilities. Strategic planning incorporated revised estimates of Soviet industrial capacity based on T-34 technical specifications. Prisoner interrogation procedures expanded to gather intelligence about Soviet tank doctrine, training methods, and operational capabilities. German intelligence officers questioned captured T-34 crew members about vehicle performance characteristics and tactical employment. Information gathered indicated systematic Soviet preparation for tank versus tank combat that contradicted previous assessments of Soviet military capabilities. Allied intelligence services monitored German tactical modifications and equipment changes resulting from T-34 encounters. British military attachés reported German requests for improved anti-tank weapons and tactical coordination procedures. American observers noted German industrial shifts toward heavier armament and enhanced armor protection. Strategic assessments recognized that German armored superiority faced serious challenges from Soviet technological development. T-34 influence extended beyond immediate battlefield encounters to reshape German strategic planning fundamentally. Operation Barbarossa timeline extensions resulted partly from increased time required for tank versus tank combat resolution. Casualty estimates required revision upward as German equipment losses exceeded planning assumptions. Resource allocation shifted toward tank replacement and improvement programs at the expense of other military priorities. Soviet military doctrine evolved to maximize T-34 advantages while compensating for crew training deficiencies and maintenance challenges. Tank brigade formations emphasized concentrated employment rather than dispersed support roles. Operational planning incorporated T-34 capabilities into offensive and defensive scenarios. Training programs focused on mechanical reliability and tactical coordination necessary for effective employment. International military observers recognized T-34 encounters as evidence of fundamental shifts in armored warfare technology and tactics. British tank development programs incorporated sloped armor concepts demonstrated by Soviet designers. American tank production plans emphasized firepower improvements necessary for engaging heavily armored opponents. Military theorists revised doctrinal assumptions about tank versus tank combat based on German and Soviet experiences. The technological arms race accelerated as both sides recognized that existing equipment advantages were temporary rather than permanent. German research and development programs prioritized anti-tank weapons capable of defeating current and anticipated Soviet armor improvements. Soviet designers continued T-34 development while investigating heavier tank designs for future requirements. Industrial capacity expansion became critical for maintaining technological parity as equipment complexity increased. T-34 encounters demonstrated that successful armored warfare required continuous technological development rather than static equipment advantages. German confidence in technological superiority faced systematic challenges from Soviet innovation that intelligence services had failed to detect or assess accurately. The tank that began as Mikhail Koshkin's engineering project had evolved into a strategic factor requiring fundamental revision of German military planning, resource allocation, and tactical doctrine across all combat arms. The T-34 tank emerged from a design bureau where political purges had eliminated experienced engineers and budget constraints limited technological experimentation. Mikhail Koshkin's team worked with outdated equipment in facilities lacking sophisticated testing apparatus, yet produced a vehicle that fundamentally challenged the world's most successful military machine. The paradox reveals how innovation often emerges from limitation rather than abundance, from necessity rather than theoretical exploration. German military intelligence, considered among the world's most sophisticated, failed to detect or assess accurately the most significant threat to German armored supremacy. Thousands of intelligence personnel, extensive reconnaissance networks, and systematic technical assessment programs missed a development that would reshape military planning across multiple theaters of operation. The failure demonstrates how organizational assumptions can blind even competent analysts to evidence contradicting established beliefs. T-34 production statistics reveal the scale of transformation that followed initial combat encounters. Soviet factories produced approximately 1,400 T-34 tanks in 1941, despite massive territorial losses and industrial disruption from German invasion. Production increased to 500 units in 1942 and peaked at over 15,000 annually by 1943. Total wartime production exceeded 57,000 vehicles, making the T-34 the most numerous tank design in military history. German responses to T-34 encounters consumed resources that might have supported other strategic priorities. Panzer IV upgrades, Tiger tank development, and anti-tank gun improvements required materials, manufacturing capacity, and engineering talent diverted from aircraft production, submarine construction, and defensive fortification programs. Soviet technological success forced German resource allocation decisions that weakened other military capabilities. Tank design philosophy shifted permanently based on principles demonstrated by T-34 encounters. Sloped armor became standard across all major military powers, appearing in American Sherman upgrades, British tank development programs, and German Panther tank designs. The integration of protection, firepower, and mobility that characterized T-34 development influenced armored vehicle design for decades following the war's conclusion. Soviet industrial capability proved far more sophisticated than German intelligence estimates suggested. T-34 metallurgy, precision manufacturing, and quality control demonstrated technological advancement that contradicted stereotypes of Soviet industrial backwardness. The disparity between perception and reality contributed to German strategic miscalculations that affected campaign planning, resource allocation, and diplomatic assessments of Soviet capabilities. Individual engineering decisions made by Koshkin's team influenced military procurement policies worldwide. Wide track design, torsion bar suspension, and simplified mechanical systems became standard features across multiple nations' tank programs. Technical innovations developed under resource constraints proved more durable and practical than sophisticated alternatives developed by wealthier military establishments. The psychological impact of T-34 encounters extended beyond German tank crews to affect strategic confidence at highest command levels. Hitler personally involved himself in tank development programs following reports of German armored inadequacy. General staff planning incorporated revised assumptions about combat duration, casualty rates, and equipment replacement requirements. Strategic optimism that had characterized early campaign planning gave way to recognition of prolonged conflict requirements. T-34 influence on post-war military thinking transcended its specific technical characteristics. NATO tank development emphasized the importance of technological surprise and continuous innovation. Warsaw Pact military doctrine built upon Soviet experience of achieving technological advantage through unconventional design approaches. Military academies studied T-34 development as an example of effective engineering management under resource constraints. Contemporary tank design continues reflecting principles established by Koshkin's team 80 years ago. Main battle tanks worldwide feature sloped armor, integrated fire control systems, and simplified maintenance procedures that originated with T-34 innovations. Modern combat vehicles balance protection, firepower, and mobility using methodologies developed during Soviet tank design programs of the late 1930s. The legacy extends beyond military applications to influence industrial design philosophy more broadly. Soviet success in developing advanced technology under resource constraints inspired development programs in emerging nations seeking technological independence. Engineering education emphasized practical problem-solving over theoretical sophistication, approaches that proved effective across multiple technical disciplines. T-34 encounters demonstrated that technological advantage requires continuous investment and innovation rather than static superiority assumptions. German confidence in equipment advantages proved temporary when confronted by opponents committed to systematic technological development. Military establishments worldwide recognized that technological complacency represented strategic vulnerability regardless of current capability levels. How many other Mikhail Koshkins worked anonymously in design bureaus, research laboratories, and development facilities worldwide, creating innovations that remained unrecognized until crisis revealed their significance? The T-34 story suggests that technological progress depends less on resources and recognition than on dedication, practical insight, and willingness to challenge conventional assumptions. Sometimes the most profound military innovations emerge from the least expected sources, transforming warfare in ways that surprised even their creators. The medium tank that began as a replacement for obsolete Soviet vehicles became the foundation for armored doctrine that influenced military thinking for generations. Its development revealed how individual engineering decisions, made under constraint and pressure, could reshape strategic balance between major powers. The T-34 demonstrated that in warfare, as in engineering, the most effective solutions often emerge from those forced to accomplish more with less, driven by necessity to discover what those with abundant resources never thought to seek. Subscribe to our channel and comment below with the city you're listening from. We'd love to know where our history reaches around the globe.